In this video, we're going to talk about how to combine like terms. First of all, what do we mean by like terms? So when we have questions such as 3x plus 2x, in this problem we have not only numbers but also variable x. The x represents unknown. So in order to combine them, we have to make sure they are like terms. So 3x and 2x, they are called like terms. And what does that mean? Because 3x also means 3 times x, 2x means 2 times x. Recall the definition of multiplication. So if we have 3 times 5, what does it mean? It means 3 5s. We have 3 5s. And how do we get 3 5s? 3 5s, then you write down 1 5, 2 5, 3 5s, 4 5s. Oh, I'm sorry, we only have 3 5s. And then you are going to add them. So 3 times 5 means adding 3 5s. So multiplication is a quick way to do addition when you add the same numbers a certain number of times. And so we got 15. And of course, we memorize multiplication table, 3 times 5 is 15. We don't have to do that, but if you don't remember the multiplication table, you can still add 5 3 times. But of course, you can also consider it as 5 3s. When you have 5 3s, that means you just add 3 5 times, which still gives you 15. Okay, so the same idea here. When you have 3x, what does it mean? It means we have 3 x's, and then we have here 2 x's, and so 3 x's just means x and plus x plus x. We got 3 x's, and 2 x's means 2x plus x. So multiplication is actually doing addition, but more quickly. So when you add them together, apparently you have 3 here, 3 x's here, and 2 x's here. Together you get a 5 x's, which can be written 5 times x. And look at the process here. It's when we add variables, and first of all we have to make sure they have the same variable. If I have y here, for example, 3x plus 2y's, and 3x means x plus x plus x, but 2y means y plus y. When we add 3x's and 2y's, we cannot get 5 copies of anything. It's not 5 copies of x, it's not 5 copies of y, it's not going to be 5 copies of x, y either. So it's not going to be any of these. So you won't be able to add them, because what we call them, we say they are not like terms. So what do we mean by saying like terms or not like terms? The variables have to match exactly. So that's what we mean by like terms. The variables must match. The numbers in front of them means how many copies. They don't have to be the same, but the variables must match. If you have x, you must have, the other one must have x. If you have y, the other one must have y. And we'll look at the process of adding them. So first we determine whether they are like terms. If they are like terms, in this case, they're both x, they match, they're like terms. The way we add is we only need to add the numbers in front of them, because we add a number of copies. So 3 copies plus 2 copies, we get 5 copies. 3 plus 2 is 5. And the variable, you just keep it. You copy it. You're not going to change it to x squared or anything. And a side note, when do we get x squared? When we do multiplication, we will get x squared. When we do addition, we're not going to get x squared. Okay, so let's look at example. So we have 7ab squared minus 2a squared b plus 6ab squared, 6, and plus 8a squared b. Now, first of all, when we look at them, that Some of them are like terms, some of them are not. For example, AB squared and AB squared. These two can be considered as like terms because their variables match. And again, when you combine like terms, when you do addition or subtraction of variables, we must make sure the variables match, or we call them like terms. We can only add or subtract the like terms. So notice these two are like terms. And similarly, a squared b and a squared b, they're like terms, they match. But ab squared and a squared b, they are not like terms. They look very close. AB squared, but this square is b squared, but that square is a squared. They don't match. They are not like terms. So you have to make sure all the letters match, all the exponents, corresponding exponents also match. So now, since addition, subtraction have commutative property, I'm sorry, not subtraction, addition has commutative property, you can put a little plus sign here, so it's sort of like we're switching these two terms. We're putting 7ab squared and 6ab squared together. And then we can move this whole thing, the sign, together with 2. Negative 2b squared plus a squared b. So we can add these two together and these two together. And when we add like terms, we only need to add the numbers in front of them. We're not going to do anything to the variables. So it's like 7 copies of this plus 6 copies of that. We're going to get a together of 13 copies of whatever that is, ab squared. And similarly, we have 8 copies of this and 2 copies minus 2 copies of that. We're going to end up with the 6 copies of whatever that is. So the variables don't change. Okay, now next, let's look at, we cannot add them further because they are not like terms. Next example, we're going to put parentheses in the problem. Alright, now if we have parentheses, we're going to, if we follow the order of operations, we're supposed to work out what's in the parentheses. So we're supposed to do negative 2 minus 2, negative 2a minus 1, and a plus 3. But, as we said before, when you review addition or subtraction of variables, we must make sure they're like terms. But negative a and negative 2, they're not like terms, and they don't have matching variables. Similarly, negative 2a, negative 1, there's not an a here, and there's not an a here. So a number and a variable, of course, they don't match. And they're not like terms. We cannot add them, And so that we have to take a different approach. And we have learned a property called Distributive Principle, and which means we can distribute a number. If it's multiplication in front of the parentheses, we can distribute that number to each term in the parentheses. So we're going to get 5 times negative a, which is negative 5a. 5 times negative 2 is negative 10. And positive 4 times negative 2a, negative 8a. Positive 4 times negative 1 is negative 4. Negative 3 times a, negative 3a. Negative 3 times positive 3, it's negative 9. So a lot of minus signs here. Make sure you pay attention to that. If you tend to forget distributing the number, distribute the number to both terms, like we often see students who forget to distribute a number to the second term, or forget to distribute the sign in front of it. You can put the number you're going to distribute on top of both terms, so you won't forget. Say I can put a 5 and a 5 on top of this, and 4 and a 4 on top of that. And if there's a minus sign, then minus sign also needs to be distributed. So you're going to have 5 times negative a, negative 5a, 5 times negative 2, negative 10, and 4 times negative 2a, and 4 times negative 1, and negative 3 times a, and negative 3 times positive 9. And now we can combine like terms. And all the ones with a's, matching a's, they are like terms. And the others with numbers, only numbers, they are considered like terms. So when we combine like terms, we only add or subtract the numbers in front of them. In this case, it's negative 5 minus 8 minus 3. So we can do that on the scratch paper. And when we do subtraction, we change it to addition. We can insert the plus sign in front of them. So negative 13 minus 3 is negative 16a. And then the other one is negative 10 minus 4, negative 9. And we're going to insert the plus sign in front of the second number. So again, negative 14 minus 9 plus negative 9, negative 23. So it's like adding a bunch of debts. So $10 debt plus $4 debt plus $9 debt will give us a negative 23. And these are not like terms which cannot be combined any further.